All right. Welcome to lesson two of our unit seven, where we're going to be continue exploring exponential and logarithmic functions. And in this lesson, we're going to be focusing on evaluating logarithms. Okay. So just to begin with, in lesson one, we took a look at the in what exactly the logarithmic function or what the log function is. Okay, and I'll just quickly go over a brief explanation of lesson one here, where we look specifically at the fact that the log, okay, so it says, and I'm focusing right here on, let me just get my pen out, focusing on this paragraph right here. Okay, where it says we have studied the exponential function f of x equals b to the x. And here it says that the inverse of the exponential function is called the logarithmic function. Conversely, the inverse of the logarithmic function is called the exponential function. So it's talking here about logarithmic being the inverse of exponential. Okay? And one of the big things that we talked about yesterday was one of the kind of the big ideas was this exponential versus logarithmic form. Okay, so this here, exponential and logarithmic form, are two different ways of writing the same thing. These two expressions are equivalent. Okay, they're equal. So a equals b to the power of c is equivalent to or the same as the log of a base b equal to c. Those two expressions are equivalent. Okay. Now we can write this as values. Okay, I can put some numbers in here, and I think I did that yesterday, but I'm going to do another example of that here. If I do 2 to the power of 4, I get 16. If I were to take the log of 16 base 2, I would get 4. Okay, so this is kind of the idea of what we're going to look at today. We're going to look at actually evaluating logs and determining their values. Okay, so quickly, just what I want to look at briefly here is I do want to just take a look again. The red graph here is our an exponential function with base 10, and the blue, is our a logarithmic function. So you can kind of see here that these two graphs are inverse of each other. We know that because inverse graphs are basically reflections along this line. Okay, the line of y equals x. And those graphs are basically, I don't know if that's quite to scale. No, that wouldn't be to scale. But those graphs are basically reflections along that line. Oops. Okay. All right. So those are what those two graphs look like. Okay. So let's get to today's lesson. So this lesson looks at evaluating logarithms. Okay. And the idea here, so again, kind of just going over yesterday again, the exponential function and a logarithmic function look like this. Okay, our exponential function is right here, y equals b to the x. And to determine our logarithmic function, what we do is we look to find the inverse. And to find the inverse, we typically switch our x and our y, we swap their values, and then we use logarithmic form or logarithmic notation to isolate for y. Okay? And basically, the idea I was showing a student yesterday, the idea of what we're doing here is we have x equals b to the power of y. And what we're going to do is we're going to get into talking about logarithmic laws shortly, but I'm just going to, just for the purpose of this right now, the main thing is that you know that taking a log is the opposite of an exponent. Okay, just like adding is the opposite of subtracting, or dividing is the opposite of multiplication, or the square root is the opposite of squaring something, or we would say inverse. Taking the log is the opposite. So if I had an equation, I'm going to go through another example here. Let's say I had x plus 2, right? And I had that equal to 4. Well, and I wanted to solve for x. I would subtract 2 on both sides, because subtracting 2 is the opposite of adding 2, or we might say the inverse, and we get x equal to 2. Let's say I had 2x equals 6. Well, to solve this, I would divide both sides by 2, because dividing is the inverse of multiplication, so those cancel out, and I get x equal to 3. The same idea goes with logarithms. If I want to solve for y here, so I want to isolate for y, what I'm going to do is I'm going to take the log base b of both sides. Okay? So notice that I took the log base b of both sides. Now this part here stays the same, as does the x. Now what we'll learn later in this unit is when you take the log, what it does is it allows you to drop your exponent. Let me just fix that g out there. It allows you to drop your exponent, the log of b base b, and the log of b base b, this here, is just equal to 1. So that goes away. And so what we have is we have log of x base b equal to y, which is what you'll see over here. Okay? And that's kind of how we do that isolating. All right, we take the log base b of both sides, and we do base b because that is our base in our power. Okay? So let's continue reading here for a little bit, and then we'll go through some examples. So it says, since x equal to b to the power of y and y equal to log of x base b are equivalent, a logarithm is an exponent. So a logarithm is considered an exponent. Okay. The expression log of x base b means, and this is what it means, this is how we read it. Where am I here? It means determine the exponent that must be applied to the base b to get the value x. For example, log of 8 base 2 means determine the exponent that must be applied to the base 2 to get 8. So basically 2, and I'll write it here, 2 to the power of what equals 8. Okay? So that's kind of the idea with that. Okay, I apologize for that. So let's continue. So what we're going to do now is we're going to complete the following table by expressing in either exponential or logarithmic form. Now remember, these things mean the same thing. Okay, so the first one says that 3 to the power of 5 is equal to 243. So if I want to write that expression in logarithmic form, I'm going to write the log base 3 of 243 equals 5. So that says that 3, basically it's saying 3 to the power of what is 243. And it's equal to 5 because 3 to the power of 5 is 243. So going the other way, it's saying 6 to the power of what is 216? Well, 6 to the power of 3 is equal to 216. Okay? The next one's saying 5 to the power of what is 0.2? Well, it's telling us that 5 to the power of negative 1 is equal to 0.2. Okay, that's what it means when it says equal to -1. The next one says 2 to the power of -3 is equal to 1/8. So we would say the log base 2 of 1/8. So log of 1/8 base 2 is equal to -3. So 2 to the power of what is 1/8? 2 to the power of -3 is 1/8. And lastly, here we have our general form, a to the power of b equals c. Well, now this is a little bit different from the way I typically write it, but going with these variables, it's going to be the log base a of c equals b. A to the power of what is equal to c? A to the power of b equals c. Okay? So that's kind of just changing form. Now, here we have the common logarithm, and then we'll get into some more examples. The expression log x is called a common logarithm. It means the base is 10. Okay? So in general, whenever we're writing just log, okay, if I write the log of anything, like the log of 5, and I don't write a base here, I leave this part blank, we assume that our base is 10. Okay? It's kind of like if I write an exponent and I don't put an exponent there, we assume that that exponent is 1. Okay? It's also the same as if I take a square root and I don't write a number here, we assume that it's a square root, that that's a 2 there. Okay? So in math, there's some numbers and things that we don't always write. In this case, if I don't write a base with a log, it means it's base 10. And so most of your calculators, when you push log, it's doing everything in base 10. Okay? So therefore, log of x means log 10 of x. These two things mean the same thing. Okay, we just don't write the 10. So now, if we look at these examples, the first one saying the log of 10 base 10 means what exponent to the base 10 is 10? Well, or 10 to the power of what is 10? And you can put this into your calculator. Log of 10 is going to give you 1 because 10 to the power of 1 is 10. The next one is 10 to the power of what is 100? Well, we know that 10 to the power of 2 is 100. The next one's saying 10 to the power of what is 10,000? Well, I know that 10 to the power of 4 is 10,000. The next one's saying 10 to the power of what is 1 over 100? Well, again, you can type this into your calculator, or maybe you know that 10 to the power of, it does this a lot when 10 to the power of -2 is 1 over 100, or 100. So you see this, the log key in your calculator will evaluate with base 10 only. Now, some of your calculators allow you to modify that base, but not all calculators do. Okay? So, let's try some questions here. Now, with these questions, we should be able to do most of these without a calculator. If you need a calculator, you can use trial and error. Okay? But I'm going to do these without a calculator, so to show you kind of that you can calculate these just using your head, or you can use trial and error. But this one is saying here, the first one is saying is that 5 to the power of what is 125? Well, 5 to the power of 3 is 125, or 5 times 5 times 5. Okay? So that's what we're doing when we're evaluating. We're determining what the answer is. The next one is saying 2 to the power of what is 1/16. When you have a fraction, you know that your exponent or your answer It has to be negative. Okay, so we just make it negative, and then we say 2 to the power of what is 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's negative 4. 2 to the power of negative 4 is 1 over 16. Now we look at this one. So this is saying 5 to the power of what is equal to the square root of 5? Well, if you did some of those practice questions or prerequisite questions, the questions that you need to do, like making sure you know, or getting started, the ones before the unit, which I assigned a few of those yesterday, you would know that 5, that the root of 5 is the same as 5 to a half. So what's my exponent? It's just a half. Okay. What would make that question mark, those two sides equal? If the question mark was a half. Okay. This one's interesting. Okay. 3 to the power of what gives negative 9? Okay. If we try that in our calculator, well, you could basically, it's saying 3 to the power of what is negative 9. Well, that's not possible. I know that 3 to the power of 2 is 9, but 3, you can't put anything, you can't have any exponent on that to get a solution. So this one, we just say that there's no solution, because 3 times 3, there's no number that I can put an exponent to get a negative number. So we just know there's no solution there. Okay. This one here, the log of the third root of 16 base 4. So what we're going to do with this one, we're going to kind of look at, we're going to kind of try to change our side of it. So what we're going to do here is we're going to write this like this. We're going to say, okay, well, 4 to the power of what? I'm going to actually use an x in this example instead of a question mark. 4 to the power of what is equal to the third root of 16? Well, can I write that as an exponent? Let's go 4 equals, that's 16 to the 1 over 3. And can I write 16 as base 4? Well, yeah, I know that 4 squared is 16. And if you know your exponent laws, a power of a power, we multiply those. So that becomes 4, to the power of x equals 4 and 2/3. So that means that x must equal 2/3. Whoops. Okay. So we're kind of changing our base there and writing our 16 as a base of 4. All right. This next one here, 1 over 3 to the power of what is going to give us 243? Well, let's think about this. So I'm going to keep this as 1 over 3 to the x equals, I know that 3 to the power of, well, 3 times 3 is 9. 9 times 3 is 27. So let's go 3, 9, 27, 81, 243. So 3 to the power of 1, 2, 3, 4, 5. So 3 to the power of 5 gives me 243. And how do I make that a fraction? Well, I make that negative. So if I go like this, if I were to make that a negative, that would give me my fraction. Okay? So we make that as negative 5. Okay? Okay, let's try this one. So this one here, we're just going to work with the two of these. We're just going to kind of work with each of these and then add them together. So log of 2 base 16. So this one is 2 to the power of what? 2 to the power of x equals 16. Well, we know that 2 to the power of 4 gives me 16. Let's do the same with this one. 3 to the power of what gives me 27? Well, 3 to the power of 3 gives me 27. Oh, 3 to the power of 3. So then here, I just know that this one's 4, this one's 3, and 4 plus 3 is 7. We're done. Now, again, doing these without a calculator can be a little bit tricky, but it's also important to kind of have that understanding of, how exactly what exactly we're doing when we're taking the logs. That's going to help you understand this unit, okay? So trying to do these in your head or without a calculator is very important. This one here, we're going to write it as the root 2 to the power of what would give me 8. So I'm going to do two things here. I'm going to say, okay, well, this is like 2 to the 1/2 x equals 8 is 2 to the power of 3. Now I'm going to say, well, 2 to the x over 2 equals 2 to the power of 3. Now, when your bases are the same, and this is kind of something that I'm going to kind of go back here just for a second and show you. Once your bases are the same, so let's look at this one, for example, right here. When your bases are the same, you can kind of cancel out your bases, and you end up with just x equals 2 over 3. Okay? In this case, so watch here. So I'm just going to do one thing here because notice my bases aren't quite the same in this one. So I'm going to make my bases the same. I'm going to get 1 over 3 to the power of x. And notice how this was negative. I'm going to apply that negative. So that flips it. Wait a minute. Because my answer is -5. Oh, when I put the negative in there, I should have flipped it initially. My apologies. So when I put the negative in here, I should have initially flipped that. So when your bases are the same, you can cross out your bases and you get x equal to -5. Okay? Again here, when your bases are the same, oh, I didn't really do that in this one because I just knew that one. When your bases are, where's another example? Let's do this one here. If I were to take this another step further, 5 to the x equals 5 to the 3. When your bases are the same, you can cross out your bases. You get x equal to 3. Okay? So that's going to kind of help here. And we want to make our bases the same. So when my bases are the same, I don't know what's happening here. When my bases are the same, I can cancel out my bases, and I get x over 2 equals 3. How do I solve that? I multiply this side by 2. And in this case, I get x equal to 6. So that's my answer. Okay, I'll do this next one with that same idea. So this one I'm going to say, okay, well, the root of 3 equals 1 over 9. Okay, well, let's make this the root, oh no, I want to kind of get my bases to be the same. So I'm going to have 3 to the 1/2. What am I doing here? I confused myself. So the root of 3 to the power of what equals 1/9. Okay, I want to make these both base 3. So I'm going to say, well, This is 3 to the power of 1 over 2 times x equals 1 over 3 squared. Now I'm close. I'm going to go 3 to the x over 2. So I combine these using multiplication. Equals, and I want this to be base 3, not base a third. So how do I flip my fraction? I make my exponent negative. Okay? So making my exponent negative flips my fraction. And now my bases are the same, so I can cross out my bases. And I'm left with x over 2 equals negative 2. My last step, multiply both sides by 2. I get x equal negative 4. So the answer to this is negative 4. Okay. Hopefully that kind of made some sense there, but that's how we're solving these logarithms, okay, or evaluating them, okay, and finding exact values. You got to practice these though. Just like anything in math, we got to practice. Okay. Next one says evaluate the following logarithms round to the nearest tenth. So all I'm going to do here is I'm going to kind of just use trial and error. Okay. So it says the nearest tenth. So I want basically, and notice what's the base here. Since there's no base, it's base 10. So 10 to the power of what is 25. Well, when it says estimate or evaluate like this, what we're going to do is we're going to use our calculator and we're going to do some estimating. So I'm basically going to say, well, 10 to the power of, let's try, it's definitely not 2, maybe 1.2. Okay, no, I'm not close. I go backspace, 1.3. Oh, we're getting closer. And it wants to the nearest tenth, so that's just one decimal place. Okay, 1.4 is pretty good. So we're going to say x equals 1.4. Or the log of 25 is 1.4. So 10 to the power of 1.4 about is 25. We're now going to try this one. So this one's interesting. So this one's saying 10 log 100. So what we're going to do first is we're going to figure out what this is first. Okay. So I'm going to solve this here. Actually, let's use a different color here. I'm going to solve this first. The log of 100 is equal to, well, that's saying that 10 to the power of what is equal to 100. Well, we know that's 2. So we know that that top is 2. So this just becomes 10 to the power of 2, which we know is 100. You can actually type this one into your calculator and you should get exactly that. Okay, three more here, and then a couple, and then just a property. So last 3 here. So evaluate each of the following. So this, okay, these are good ones. So this is saying here, 5 to the power of what is equal to 1. Well, hopefully we know that anything to the power of 0 is equal to 1. So that's equal to 0. This one here is saying 3 to the power of what? Well, let's do that as an x. 3 to the power of what is equal to 3 squared? Well, we know that 3 squared is, well, actually, weird. Look at that. These just cancel out. Those bases are the same, so we're just left with x equals 2. So that's just 2. Notice that's my answer right there. And the last one, this is saying, and this is kind of like the one we did up there, but this is saying First, we would have to evaluate this piece. Okay? So 4 to the power of what is 25? Exponent form. So this one here, we want to know what this is equal to. So we're gonna say this is equal to x. Okay. And what we're gonna do here is we are going to put this into logarithmic form. Wait a minute. Yeah. So we're going to do the log base 4. So this here is like exponent form. And we're going to change it to logarithmic form. So remember that's like this. I'll do my version. Oh yeah, A equals B to the power of C. Okay, so our A in this case is the 4. Oh no, wait. Wow, I'm all mixed up here. Our A in this case is the X, our B is our 4, and our C is this top piece here. And how do I change that? Well, that changes to the log base B of A equals C. So watch this one. The log base 4 of X is equal to log base 4 of 25. Notice that these two pieces are the same. Because those two pieces are the same, for these two things to equal, x must equal 25. Okay. And so these three examples here take us to our final properties, or our final point. Okay. And our final point are these three properties. The log, no matter what b is, in this case, no matter what b is, if it's the log of 1 base anything, your answer is always 0. Okay. Our next one says that if it's log of b to the power of x base b, your answer is always x. So that's our second example. Okay, notice how our answer was 2. Our answer was our exponent. That's the case here. And the last one is when your base and your exponent are the same thing. So this is written wrong. This one is written wrong. So this should be b log base b of x is equal to x. And that's our last example from above. Okay, so you can use those properties to kind of help you solve. So there's your homework. It's a little bit more than yesterday. Let's check how much time you should have. That should be posted. Hopefully the supplier who's ever in there will write that on the board for you. And we should be at 33 minutes. So that was a rather quick lesson. You should have a decent amount of time then to work on that homework. So work away. Like I said, I'll be back Friday. We're going to have a quiz probably next Monday, and we're gonna have a quiz next Monday. So and it'll be on the first of these 3 lessons. So it's gonna be yesterday's lesson, today's lesson, Thursday's lesson. We'll do a review period on Thursday. We'll do a quiz on Monday, and then we'll have a couple lessons left before our test, which will be at the end of next week. Okay. We'll talk to you later. Try those questions out, and have a great rest of your day.